Hello everybody, welcome to our Science Cafe. My talk is about Introduction to QSAR Descriptor. QSAR is meaning Quantitative Structure Activity Relationship. It measures the relation between the physicochemical properties of the molecules and their biological activity. Based on the determination of mathematical equation, we can express the biological activity of these molecules in terms of molecular descriptor. So we can make a correlation between structure and activity for any different number of compounds and molecules, and after that we can select the promising compound to be sensed and tested in laboratory. The first formulation that describes the relation between the chemical structure and the biological activity was postulated in 1868 by Crum Brown and Fercier when they study the biological effect of different alkylation of the basic nitrogen atom in ammonium compound as compared to the basic amine. They found that the physiological action of the substance phi was a function of its chemical composition, and this mathematical equation as can be easy to make a molecular descriptor for QSR. There are several of physical, structure, and chemical descriptors used in QSR approach. The three most commonly studied descriptors are: first, electronic parameter, which determine electron distribution, and it will affect on molecule ionization and polarity, so it will give information about the activity of this molecule. The second one is hydrophobic or lipophilic parameter, which measure molecule solubility to have the information about this molecule to be interact with the other molecule in solubility, and also to have information if this molecule will be go through the lipid membrane. The third one is the steric parameter, which is depend on the size and shape of molecule to determine whether this molecule is able to get close enough to other molecule in order to bind it in the binding site of it. Electronic parameter has a different molecular descriptor, and the most common one is quantum chemical descriptor because it's more accurate and give detailed description of electronic effect, and have a different molecular descriptor as net atomic charge, which give information about the total charge of the molecule. And if the molecule are in ground state, not in the excited state, the total charge of the molecule will be equal zero. Also, HOMO and LOMO energy. The difference between the LOMO and HOMO energy will give information about the molecular orbital energy gap. The smaller the energy gap of the molecule, the more reactivity of the molecule to be interact with the surrounding media. Also, it give information about the absolute hardness, and also have information about the softness to know if we have a substitution of the molecule with the other ions or atom, so we can know which atom or which ions we can interact with the molecule. Also, molecular permeability, which has tendency of the charge distribution, so we have information about the volume of the structure to be interact with the biological system. Molecular dipole moment, which is equal to charge separation, and give information about the molecular activity. If the total dipole moment of the molecule increase, its molecular activity increase, and it will be able to interact with the other tissue. The total energy. Total energy will give information about the total energy of the whole molecule, and lower the value of the total energy of the molecule, the more stable of this molecule. The heat of formation, which is give information about the energy released or used when the molecule is formed. So it will have a change in the enthalpy of all the molecule. The last one is the ionization potential, which is the electron detached energy, or the energy required to remove an electron from the molecule to infinite distance. And if the value of the ionization potential is low, it will be easy to remove an electron. And if it's high, so it can be hardly to remove an electron and interact with other compound. The second type of QSR molecular descriptor is hydrophobic lipophilic parameter, which is known as a partition coefficient. Log B of partition coefficient for the compound is the logarithm base 10 of partition coefficient, which is defined as the ratio of the molecule concentration in non-aqueous or organic medium and aqueous phases of to the compartment. The log B gives the information about the compound, whether it is hydrophilic or hydrophobic molecule. If the value of the log B is lower or negative, So the structure will be hydrophilic. And if the value of the log B is high or highly positive, the structure will be hydrophobic. The last QSR molecular descriptor is steric parameter, and the most widely used steric parameter in QSR studies is the molar refractivity. Molar refractivity is related to the molar volume and the refractive index, according to this equation. So the molar refractivity is depend on the volume, like polarizability of the molecule. So if they increase the molar refractivity of the structure, so it's highly interact with the surrounding tissue and will be available to be able to in any biological application. For this time, we have all the descriptor for QSR molecular descriptor, and we show that how it will be interact with the other tissue. And in the next time, we will see an example for this descriptor. Thanks a lot.